The learning targets for this lesson are: I can provide a verbal description for a qualitative graph, and I can sketch a qualitative graph when given a verbal description. So here's an example of a qualitative graph down here. Qualitative graphs are graphs used to represent situations that may not have numerical values, or graphs in which numerical values are not included. So you're going to see that on the x-axis and on the y-axis, there are no numbers except this number 0. A graph is used to show the relationship between two variables. The variable on the horizontal axis, or the x-axis, is called the independent variable. Independent variable. This means that this variable provides the input values for this relationship. The variable on the vertical axis, or the y-axis, is the dependent variable. Dependent variable. This means that this variable provides the output values for this relationship. All right, let's go over example number 1 of a daily commute as shown here below. Let me zoom out. The graph above represents Ren's distance from home during the course of a school day. Each school day, Ren walks to his friend's house to get a ride from school. After school, Ren is picked up by the same friend's mom and driven back to his friend's house. From there, Ren walks the rest of the way home. What is the independent variable? Well, looking at the x-axis, the independent variable is time. What is the dependent variable? The y-axis. It's distance from home. So let's just look at this graph for a second and make sure it makes sense. So he starts with his distance from home at 0. That means he starts at home. And it says he walks to his friend's house to get a ride from school. When the slope is positive, the distance from home is increasing. So he's increasing his distance from home to get to his friend's house. When the slope is 0, he's staying the exact same distance from home. So maybe he's at his friend's house for a short period of time. Then it looks like the slope is positive again. So he's gaining distance away from home. This would be when he's in the car getting a ride to school. And see how the slope is a little steeper? It's because he's moving quicker than if he was just walking. Then here the slope is 0 for a long period of time. His distance from home doesn't change. That's probably when he's actually at school. Then this portion, his distance from home is decreasing, meaning he's getting closer to home, which is probably when his friend's mom drives them back to their friend's house. He looks like he's there for a little while, and then he walks the rest of the way until the distance from home is 0, meaning he's back at home. So label each section of the graph above as increasing, decreasing, or 0. When there's a positive slope, he's increasing his distance from home. So this is when he's increasing his distance from home. When there's a 0 slope, there's 0 change in his distance from home. Here at this section as well, he's also increasing his distance from home. And then here there's a 0 slope, which means there's 0 change in his distance from home. That's when he's staying at school. Now here we have a negative slope. He's decreasing his distance from home. In other words, he's getting closer to home. Then we have another plateau right here, which is another 0 change. And then finally, there's another decrease in this relationship until he's finally at home. And that is one way to interpret a qualitative graph. So on example 2, we're given another qualitative graph, and this example is done for us. So we're going to notice that the axes are labeled, but they don't include numerical values. So this is the photos that are downloaded, in the time it took in minutes. And you can see the relationship between the time and the number of photos downloaded. And if you were asked to describe the change in photos downloaded over time, here's a good example answer. The graph shows that someone downloaded some photos where the segment is increasing. So downloading photos while it's increasing. Then when the segment is horizontal, there were no photos being downloaded. The rate at which photos were downloaded increases again. Ooh, a lot of quick downloads of photos right here, followed by another horizontal segment where there's no photos being downloaded. This time they stop for a longer period of time before downloading more pictures. So in example 3, we're given a qualitative graph and we are asked to describe what's happening in the qualitative graph. So first, just so we know, this is a positive slope right here, which means there's going to be an increase in the relationship. So when we describe it, we can keep that in mind. Here is a horizontal portion where the slope is 0. There's a 0 change in the relationship right there. And then here we're seeing a decrease. All right, let's read what this problem is about. The graph below displays the water level in a bathtub. Describe the change in water level over time. All right, well, let's take a look. At the very beginning of this problem, the water level in inches is 0. So the tub starts empty. So I'm going to say at time 0, the tub is empty. All right, now let's take a look at this increase in the function. So the water level is increasing, so they probably turn the water on, and that is a straight line. So the water level increases at a steady rate. It increases at a constant rate. So I'm going to say the water's turned on. The water is turned on. And not only is it turned on, but it increases at a constant rate. And the water level increases at a constant rate. All right. Then I noticed this horizontal line right here. During this time, the water level stays the same. So they must have turned the water off and the water level stays the same. So the water is turned off. And stays the same level. It's probably when they're actually having a tub. Okay, and then finally you're going to see that there is a decrease in the water level all the way until the tub is empty. And that decrease is a straight line, so that means that the tub is emptying at a constant rate. So I'm going to say the plug is pulled. And water decreases at a constant rate until the tub is empty. And water decreases at a constant rate until the tub is empty. I know this is a lot of writing. There's going to be some writing today. I know. It's going to be fine. You'll get through it. So here we go. At time 0, the tub is empty. The water is turned on and the water level increases at a constant rate. The water is turned off and stays the same level. The plug is pulled. The water decreases at a constant rate until the tub is empty. Okay, let's go to the next page. So practice problems. The graph below displays the temperature throughout the day. Describe the change in temperature over time. So this is not a straight line. This is a curved line. So we're not going to say that the temperature is increasing or decreasing at a constant rate. This is a varied rate because we see a curvature in the relationship. So I'm going to say first the temperature increases at a varied rate. So first, the temperature increases at a varied rate. And it does that until it hits some kind of maximum point we see right here. So I'm going to say until it reaches a maximum. Until it reaches its maximum. All right, and then it says that the temperature is going to decrease. It decreases at a varied rate, but it's a more steady rate. It's a slower rate until the temperature is back where it started. It's back to the original temperature. So then I'm going to say the temperature decreases at a varied but slower rate. The temperature decreases at a varied, it's curved, but slower rate until the temperature is right back where it started. Until it's back at its original temperature. All right, let's look at this next one. The graph below represents revenue for a local clothing store. So this is how much the clothing store made. Describe the sales over time. So mostly I'm seeing the sales increase over time, but there are a couple dips along the way. Like here, I see the sales decrease over time. And then here, this almost looks like a plateau area where the sales remained the same. So I'm going to say overall, the sales increase over time, and then I'm going to make a statement about those two circled areas. So overall, sales increase over time. But at the two circled points, the sales decrease or remain constant. The sales decrease or remain constant. Okay. Next one. Okay, whenever there's something like this and it's like a pattern, I usually just describe what is happening in the first iteration. And then I just say this cycle repeats 2 more times or however many times. So that's what I'm going to do here. I'm just going to describe the first pattern, and then I'm going to say that it repeats. So the graph below displays the speed of a city bus as it stops frequently to pick up passengers. So describe the change in speed over time. So what does the speed start at? It starts at 0. So the bus is stopped at the very beginning. The bus is stopped. The bus is stopped. Okay, then the bus increases its speed until we get to this point. And then it looks like it maintains that speed while the line is horizontal. So I'm going to explain this part first. I'm going to highlight it in green. And I'm going to say the bus increases speed at a constant rate. The bus increases speed at a constant rate. Then here when the slope is 0, the speed of the bus stays the same. So the speed of the bus stays the same. Okay. Then we see a decrease in the speed. So the bus has to slow down until it comes to a stop, probably to let passengers on and off, right? So the bus decreases speed at a constant rate until it is stopped. And I say constant rate because that's a straight line. The bus decreases speed at a constant rate until it is stopped. Okay. Then the last thing I do is I only really described this part. So now I'm just going to state that this pattern occurs 2 more times. This pattern occurs 2 more times. All right. Once you're done with that, go ahead and turn the page. A tennis ball is dropped onto the floor. On each successive bounce, it rebounds to a height less than its previous bounce height until it comes to the rest on the floor. Sketch a qualitative graph to represent the situation. So for this graph, I'm going to let time be my x-axis. And since we're talking about the distance from the tennis ball to the floor, I'm going to say distance from the floor is my y-axis. Distance from floor. Okay, so now since the tennis ball is dropped onto the floor, it's going to start at some distance that is higher than the 0. So it's going to start at some high distance. It's going to be dropped onto the floor, which means the distance from the floor is going to become 0. And at each successive bounce, it rebounds. So it's going to bounce, but it's going to rebound to a height less than its previous bounce height until it comes to a rest on the floor. So it doesn't tell us how many times this happens, but we can make a guess. And that would be my qualitative graph until the tennis ball is on the floor, and the distance from the floor would be 0. An athlete alternates between running and walking during a workout. Sketch a qualitative graph to represent the situation. So since we're running and then walking, our speed is going to change. And speed is comparing distance and time. At the very beginning, your distance that you traveled is 0. And the athlete's going to run, which means the rate of change is going to be pretty fast because they're running. And then they're going to walk, which means they're still going to increase their distance, but it's going to be at a more casual rate. Then they're going to run, which means they're still going to increase their distance, but at a more sharp, steep rate. And then they're going to walk, which is going to be a more gradual rate. So that's my qualitative graph. Every time the graph is really steep, that is representing when the athlete's going to run. And every time my graph is more gradual, that's when the athlete is walking. The temperature of a cup of hot cocoa cools down rapidly in the beginning. Then it cools down at a slower rate and it levels off. Because if you think about it, the cup of hot cocoa is not going to just keep getting colder and colder until it's an ice cube. It's going to get colder until it's room temperature, and then it's going to level off. Sketch a qualitative graph to represent the situation. So I'm going to make time as my x-axis, and my y-axis I'm going to write temperature, but I'm going to abbreviate it as temp. So the very first thing it says is it's hot chocolate. So the temperature is pretty hot. And it's going to cool down rapidly, which means the temperature is going to decrease. And since it says rapidly, we're going to make it a steep decrease. Then it cools at a slower rate. So it's going to cool at a slower rate. So still a decrease, but more gradual. And then it's going to level off. So maybe that's when it gets to room temperature. It's going to stop decreasing, and it'll stay the same temperature as the room. All right. Okay. Which of the following graphs shows you the relationship between the length of a yo-yo string and the amount of time spent playing with the yo-yo? Now, I don't know what you guys know about a yo-yo, but to start a yo-yo, like here's a yo-yo, you have to start with its string all coiled up. And then you have to release it down, and then it looks like this, where the yo-yo string's really, really long. And then the yo-yo kind of like comes back up to the string to be all wound up, and then you release it again, and then the yo-yo string is really, really long again. So which one of these graphs shows the yo-yo string being completely wound up, and then pretty long, and then completely wound up, and then pretty long? And the answer would be this one, because the yo-yo string has to start completely wound up, and then get longer, and then get completely wound up again, and then get longer, and then get completely wound up again, and so on. Okay. Bob is 28 years old. Which of the following graphs shows the relationship between Bob's age and his height? So Bob would start off growing until he reaches a certain age, and then he would level off. I know some people, quote unquote, like shrink as they get older, but Bob's only 28. So which graph shows Bob gradually getting taller and then leveling off to his adult height? Answer would be C. Okay, last one. Match the graph with the correct title. What should each of the axes be labeled? So daily snowfall amounts in February, year 2000. Monthly average temperature in Tampa for the year of 2005. And the population of San Francisco, California. I think the population of San Francisco, California might be the easiest one to start with, because ever since we moved out west as a country, San Francisco's population has just grown and grown and grown. So which one of these just shows consistent growth? The answer is B. And if I had to say what would the axes be labeled, I would say time would go here, like years, for example, and population would go here. Okay. So really we're debating between A and C for daily snowfall amounts in February and monthly average temperature in Tampa. So daily snowfall amounts. Some days could get 0 snowfall. Some days could get 1 inch of snowfall. Some days could get 10 inches of snowfall. Then you could be at 0 again. Which one of these just shows really choppy changes from day to day? The answer would be C. And I could label this as time, like by day, right? It's days, daily snowfall. And this would be snowfall for my y-axis. Monthly average temperature in Tampa. So does this make sense? Could this be like the January temperature, then the February, then the March, then the April, then the May, then the June, then the July, then the August, and September? Yes. So this one would be the monthly average temperature in Tampa. And I would say temperature would go here, and time would go here, and it would be time in months.